right, so in this video, we are going to be talking about circuits a little more. In the last video, we talked about current, resistance, and voltage and how we use Ohm's law to analyze a circuit. We're going to take that one step further and talk about different formats of circuits in this video. So you will see we've got two different formats. We have series and parallel circuits. Our objective in this video is to be able to compare and calculate current, resistance, and voltage used by electric circuit elements in series and parallel formations. Your essential question for this video today is, how do we use Ohm's law to calculate values in series and parallel circuits? So we are going to look at the difference between these two circuits, and we're going to look at how to calculate these different values. And so hopefully this is going to take it one step further in your understanding of how to calculate various values in these different types of circuits. Now, I've set my notes up, so I'm kind of dividing the page down the middle so we can really compare and contrast to these two different circuit formats. If there's another note-taking method that works better for you, that is totally fine. Please just make sure you include the objective and essential question as well as your summary at the end of your notes today. So let's go ahead and zoom in on what we are looking at here. Now we've got these two different types of circuits. We have series circuits and parallel circuits. So I want you all to just look first at the difference and how they look different when how they are depicted. So you will notice if we look over on the left side of the screen, we have a series circuit over here. A series circuit is when there's only one path through which the current can flow. So the current there's only one wire. The current can only flow out of that one wire all the way around to the negative terminal of the battery. In contrast, if you look over to the right side of the screen, you will see a parallel circuit. And in a parallel circuit, there actually is more than one path for the current to follow. You'll start to see these branches with resistors in them. So that is a parallel circuit. There's different branches for the current to follow there. So that's the main difference between series circuits and parallel circuits. Now, resistance, current, and voltage is going to look a little bit different across these two different types of circuits. So I'm going to go over each term one by one. Let's start with our resistance in a series circuit. So looking over to the left side of the screen right now. Now, in a series circuit, the total resistance of the circuits, total, is going to be equal to the sum of the resistance of all of the resistors. So you'll see on this series circuits, there are three resistors right here. So we've got R1, R2, and R3. We're just going to add their resistance together to get the total amount of resistance of the circuit. Now, I added these three dots to indicate that if there were more resistors in that circuit, you would just add that resistance as well to get the total. So if there was a fourth resistor, whatever that resistance of that fourth resistor is going to be added to get the total resistance as well. Now, here's where things get a little bit interesting. I want you to think about how you calculate the total resistance of a series circuit, and now look at how you would calculate the total resistance of a parallel circuit. We have a little bit different of an equation here. All right, so while a series circuit, we are just adding those values together, a parallel circuit, you are actually using the reciprocal of these values to get the total resistance of a parallel circuit. So 1 over the total resistance of a parallel circuit is equal to 1 over the resistance of the first resistor plus 1 over the resistance of the second resistor plus 1 over the resistance of the third resistor. So it does create this new interesting equation here. We are comparing series and parallel circuits and the resistance within them. Thankfully, our unit of measurement for resistance does not change. We are still measuring this in ohms, right? But what is really unique about parallel circuits, and this is only for parallel circuits, so series circuits, this does not work. But as more resistors are added in parallel, the total resistance of the parallel circuit decreases because you're actually adding more pathways. So if we were to add another resistor, another branch, maybe two more branches, what's happening here is that total resistance is going to decrease because you are adding more pathways, more branches for the current to travel through in that parallel circuit. So again, that is just for parallel circuits. Series circuits, it's just the sum of the resistors. So you'll actually notice the resistance increases as you go across the series circuit, since you are simply just adding the resistance of those resistors together. All right, moving on to current. Now you will notice that current is also going to be different and calculated differently depending on what, I used the wrong color there, depending on what the format is of the circuit. So in a series circuit, the current is going to be the same no matter where you are in the circuit. So you'll notice I've added these different little points across the circuit. I've got I1 here, I2, I3. Those are just marking different points across the series circuit. However, the current is going to stay the same regardless, right? So again, I've kind of written this out here as well. The total current remains the same throughout a series circuit. No matter where you are in the circuit, in a series circuit, the total current is going to be the same. Now, current is still measured in amperes. We call it amps for short. We're using that capital A to measure the current here. Now, in contrast, you will notice that the total current in a parallel circuit is actually going to be calculated by adding the different currents through those different resistors together. So because we have these separate branches in a parallel circuit, that's going to result in us having different currents going through these different branches. Since they have these electric charges have more paths to follow in a parallel circuit, we might not have the same current across all three branches of this circuit. So the total current is simply going to be calculated by adding the currents together in that circuit here. Now, finally, we'll go over voltage. So the voltage, again, remember what voltage is. It's kind of just I want you to think of voltage as the battery, how much the battery is putting into that circuit. It's the difference between 2 points, difference in electrical energy between 2 points on that electric circuit. So I want you to think about those 2 points as those two terminals on the battery in that electric circuit. So the voltage of a series circuit is just going to be added. The different voltages are going to be added together here. Now, with that in mind, there is a voltage drop in a series circuit. So what's happening here, and I will scroll up so you all can kind of see that. The voltage of the battery, where it starts off at this positive terminal here. And this positive terminal, I want to get my highlighter out instead. When the voltage starts at this positive terminal, it's going to have a certain value. As the current goes through this electric circuit back to the negative terminal of the battery, the entire voltage is going to drop to 0. So you'll start to see at different points across the circuit, the voltage is going to drop until it eventually reaches 0 when it returns to this negative terminal of the battery. Now, when that voltage drops, it's going to drop the same value of the number of volts in that battery. So what I'm saying is, if you have a 10 volt battery, let's just say, I'm going to get a different color on the screen here. Try to get it to match. So say you were given a 10 volt battery here to power up this circuit, right? It is going to start to lose that voltage. So it might be 8 volts here, and then it might be, 6 volts here, and then maybe 3 volts here. And then all of a sudden, once it gets past this final resistor, it reaches 0 volts. All right, so that voltage is starting to, and I did my math wrong, so I want to make sure those add up together. So this voltage is going to decrease, but you'll notice that when it starts up, okay, it would be until it reaches that first resistor, it's going to be 10 volts, and then it's going to drop, and it's going to continue dropping as it goes all the way across this circuit and eventually reaches 0 volts. Now, the difference between these 10 volts and 0 is 10. So that's where we get this idea of that difference in electrical potential energy as what voltage really is. So again, the total voltage in a series circuit is simply the addition of those different points in that series circuit. You're just adding the voltage together at any given point in a series circuit. Now, a parallel circuit's a little bit easier to remember. Because a parallel circuit has these different pathways, we don't have to worry about this voltage dropping as the current goes across, as these charges move across the electric circuit. So you will actually see that at any given point in a parallel circuit, so if you're here, wherever, the voltage is going to remain the same. So the voltage is the same across all components of a parallel circuit. Now, this is, again, we're talking about total current, total voltage, total resistance so far. If you wanted to calculate the individual voltage or resistance or individual current or resistance in a parallel circuit, you're going to use Ohm's law. So say we wanted to just know the individual resistance of this point in the circuit, I2, where it goes through the second resistor and it has that voltage too. This is where you will be using Ohm's law. You're going to use these 3 values for Ohm's law here. However, if you want to know the total current, that's when we're going to look to this equation here. So just note that there is a difference between what we are doing when we are looking at an individual point on a circuit versus the total current, voltage, and resistance of a circuit. Okay, now I know that was a lot of equations, a lot of explanations, but I did want to get through one example problem so that we can kind of see this play out. So I've included an example here. And let me just zoom out a tad. Okay. So sometimes things get a little funky and we can actually combine series and parallel circuits. So I want you all to take a look at this circuit I've drawn, and you will notice that we have elements of both series and parallel circuits here. Now we've got these multiple branches here, but within that second branch, we have two resistors here. It's kind of creating this network here. So we have both, I'm going to put a series and a parallel circuit to indicate that both elements are being combined in this problem. So I intentionally chose this problem because both of these elements are going to be combined together here. Now, this one asked us to calculate the total current, resistance, and voltage of this circuit. Okay, so I want you all to notice that overall, this is a big parallel circuit. Now, we do have two resistors positioned in a series here in one of the branches of the parallel circuit. But overall, this is going to be a parallel circuit. So with that in mind, I'm going to look to some of my parallel circuit elements and how to calculate some of those. So let's go ahead and start off by calculating our total current of this circuit. So I am going to do this in green to match the current color here. And I'm going to go ahead and actually skip over these 4 steps because I do want to make sure we have room to include all these calculations on here, and also just for the sake of time. So we're going to start with the total current. And we know that the total current for a parallel circuit, if we scroll up, is going to be equal to the sum of all the currents within that parallel circuit. So we see that we have 2 currents here. We've got 5 amps and 2 amps. So we're going to add those currents together here. And I'm going to say we've got 2 currents. So I1 for the first current, I2 for the second current, right? And then to calculate our total current, we are simply going to add whatever we're plugging in for I1, which will say I1 is going to be 5 plus whatever we're plugging in for I2, which we say is going to be 2. And that gives us a total current of 7 amps for that parallel circuit, this parallel circuit below. Okay. Now let's go ahead and move on to calculate the resistance. Now again, we are looking at an overall parallel circuit since we have these branches here, but we do have these 2 resistors which are in a series formation. So we're actually going to do, let's just briefly do 2 different calculations here. And actually I'm going to label these. So we've got our R1, R2, and R3. All right, and then I'm actually going to quickly say that this 5 amps was I1. This 2 amps was I2, just to keep track of these variables here. So you've got R1, R2, and R3. We know their resistance, the resistance of R1, R2, and R3. So let's go ahead and start off just by calculating the resistance of this series, or these resistors in series. So to calculate the resistance of R2 and R3, that's our series that we're looking at. We are going to add together the resistance of R2 plus our R3. Now, if we look, we see our resistance for R2 is 5 ohms, and the resistance for R3 is also 5 ohms. 5 plus 5 is going to be equal to 10 ohms. So we now know the total resistance between these two circuits is now going to be equal to 10 ohms. Okay, so all we did was we just said, all right, let's break this up. Let's look at this part where it's in a series first. So then we could now get the total resistance and tack on that resistance for R1. Now remember, our total resistance, we are going to be using our equation for a parallel circuit. So our total is actually going to be 1 over the total resistance. And we're going to use our reciprocal equation. So 1 over R1 is equal to 1 over the resistance between R2 and R3. So I'm just going to say R2 and R3, which we already calculated up here. I'm going to scroll down to make a little bit more room. I'm going to leave this equation, this side of the equation as is. But we can go ahead and start plugging in numbers here. So 1 over our R1, I'll scroll up just to verify what R1 is equal to 10 ohms. One over R2 and R3, which we already calculated, is also equal to 10 ohms. So if we add 1/10 and another 1/10 together, we get 2/10. Remember, when we're adding fractions, we need to make sure the denominator is the same. This part on the bottom is the same. And then all we have to do is add the numbers on the top, add the numerator together to add those fractions. So 1/10 plus 1/10 is equal to 2/10. Now 2/10 is equal to 1 over the total resistance. If we want the total resistance, we are going to actually have to flip these two fractions. All right, so all we're going to do now is flip that fraction. So our total is on the top. Now we've got 10 over 2. Now our total, or R divided by 1, is just the resistance, the total resistance. 10 divided by 2 is equal to 5. So our total resistance for this parallel circuit is going to be equal to 5 ohms. And I'll scroll up so you all can see. And I'm just going to box these answers in. So we've got our total current, and now we've got our total resistance. Now, in this drawing, we are not given any indication of different voltages, but we do know an equation that uses current and resistance to calculate the voltage, and that is Ohm's law. So to calculate our total voltage here, we can use our total current times our total resistance. This is how we're going to get our total voltage. So I'm going to rewrite that on the side here, right? We know that our total current is equal to 7. Multiply 7 by our total resistance, which we know is equal to 5. And that will actually give us a total voltage of 35 volts. So again, that was a pretty challenging problem, but I did want to show you all kind of what it looks like to put all of these equations together. So we actually really just solved 3 problems there in the span of a few minutes, but I wanted you all to see how we can kind of combine elements of series and parallel circuits to calculate the total current, voltage, and resistance of any sort of circuit format that you are given. So again, go ahead and review your notes on this video, and please make sure to write a 1 to 2 sentence summary about what you learned using that essential question. And I look forward to discussing this more with you all in class.